Action! Action!
Did you know that heat can change the temperature of things? And that can flow also if the molecules don't touch each other.
This is not the intro!
Ayo. Before talking about heat, we need to understand what is temperature. Temperature in physics is described as the average kinetic energy of each molecule in a substance. If we get the average kinetic energy and we multiply for the amount of molecule, we get another very important parameter, which is thermal energy. The amount of thermal energy that is removed from or added to a system is what we call heat. In other words, heat is the energy that is transferred between systems when they are at different temperature. No difference in temperature, no heat transfer. Period. So the heat that flows changes the temperature of a system. Exactly how much is dependent by two factors. The mass of the system. The more matter a system has, the more heat is required to change its temperature, and the parameter called specific heat, which measures the willingness of a system to change its temperature. For example, water has a much higher specific heat than steel. This means that it takes much more heat to change the temperature of water compared to steel. Put it this way, it takes less heat to increase the temperature of the pot rather than the water where you have to cook your pasta. Bad news. If you like pasta, of course. So, how does heat transfer? Well, there are three ways: conduction, convection, and radiation. Let's run some experiment to fully understand them. In conduction, heat flows or transfers relying on physical contact between molecules, which transfer their kinetic energy among each other. Like this piece of ice and this block of steel. The block of steel is at room temperature while the ice is, well, around 0 degrees, more or less. If we put them into contact, heat will flow from the block of steel to the ice, causing the ice to melt. And at the same time, the steel will get colder. The heat transfer stops when both will be at the same temperature. Now the question could be, what determines how much heat gets transferred over time? Well, generally, the bigger is the difference in temperature, the faster the heat flows. In this experiment, one of the blocks have been heated. However, conductivity also depends on the material. Metal, for example, conducts heat much faster than wood does. Another way heat can transfer is by convection, as we said, which is kind of like conduction, since it still depends on contact between molecules. In convection, though, the molecules do not just bump into each other because they are nearby. Instead, they travel much farther. This tank contains very cold water. After putting the food coloring, I will heat up just the center of the tank. As you can see, the red food coloring rises because the water there is getting hotter. Basically, the hot molecules of water move away from the heat source and are replaced by cooler molecules, represented by the blue food coloring, which are then heated up. If you pay attention, you can see a circular motion forming on both sides of the column of water that is very hot in the center. These are called convection cells. The motion finally stops when the temperature of the water is homogeneous. This though happens because the heat source is coming from the bottom. If we heat the water from the top, the hot water cannot rise and then create the convection cell we have seen. It will rather stay put and do not move. Finally, there is radiation, which does not depend on contact between molecules. Instead, heat is transferred by electromagnetic waves, like the light coming from the sun. If you ever stood in the sun, which I'm pretty sure you did, you have already experienced it. The heat you can feel, especially in summer, is heat transferred by radiation by the sunlight. We can demonstrate radiation with a very cool experiment, and for that I need a very special substance. Slime. Well, not any slime. In this slime I have mixed a thermo powder. Pay attention to the color. If then I heat it, the halogen light generates a nice heat. If you'd put your hand near it, you'd feel the warmth reaching your hand, like the slime right now. As you notice, the slime slowly changes its color due to a heat transfer by the electromagnetic wave, light, that the halogen light is generating. I hope you have learned a lot of things about heat transfer and that now you can share it with others. If you have enjoyed the video, please consider giving it a thumbs up, as well as subscribe to the channel if you want to see more videos like this. And as usual, thanks for watching.